that your application is safe from any attacks from those. Not that they are deliberately malicious, but their applications could have loopholes. So the attackers don't necessarily have to attack your application directly. They may go through other applications to get in, right? There are other vectors. So the challenges are way different. So unknown, untrusted infrastructure, concern of this from being consolidated like this, right? So I think we have talked about all these. So we'll move on. We'll list some of the products we can talk about them a little later. So the other thing, like I was saying, let's focus on, if you don't see what's in the infrastructure, you can't manage it. So dynamic data centers, lack of visibility, unprotected virtual machines, if they're there, then you're not secure, right? Then agentless machines, so where you don't have your trusted processes telling you what's going on. Then so you don't have physical control. Hybrid and public cloud, different kinds of architectures. So you may have certain things in Amazon, something in VMware, something in your own, etc. So how do you have a little more consolidated view? So that is the challenge, right? Then the root of trust we talked about. How do I know that a machine came out the way it's supposed to come out, right? And of course, administration, the compliance, the regulations, those are the other aspects, because especially if you're running critical bank applications or health and those kinds, you're not exempt from, just because you're in the cloud, you're not exempt from compliance and of data privacy or data movement. So what we are suggesting is that you must have a single pane of glass. You must have something that converges all that is happening in your application, your infrastructure, and first of all, let's get the visibility, the visualization of the infrastructure end to end, right? It's only once you get that, then you can start going back and saying what is your security tolerance, what can run where, when you want to be alerted, the monitoring and controlling aspects. The vectors, attack vectors have changed. It's no longer just to the perimeter, to the network, so just having one single firewall is no longer sufficient. You need to worry about what is happening in the whole, on a given hypervisor, different VMs, what's going on. So you probably need something like a virtual firewall or a virtual intrusion prevention appliance. You cannot have one intrusion prevention appliance sitting on the perimeter and route all traffic through that. So you need things that are going to be at hypervisor level, at intra VM level. Right? So you're getting things in databases. The database vulnerabilities are on the rise. Yeah, because that's where the data, right? It's about getting to the data. Then emails continue to be the weak link. Worms, etc. Those continue. Just one user clicking somewhere, right? So you've now provisioned all these virtual images, desktops to people, right? What if somebody clicks some email there, and they click that email, it's open some attachment, it's done. Now it's started to percolate in the VM. So you're now all happening within the intranet, right? Or the intra data center, intra cloud kind of situation. So you need to look at database vulnerability managers, activity monitoring, then email gateways. These are all things that existed. So they're all going to go virtual as well. So that's the push that's happening. So what could be a single appliance or a farm of appliances is now going virtual so that it can scale. Let's talk about something specific. Why did we go virtual? Why have people gone? Why have the CIOs gone virtual? They've gone virtual because they can get the scale. They can get more for less. So with lesser hardware, we can do more. If you're using lesser hardware and the more virtual machines you can put on a given hardware, that means that's much more computing power for you. If that is that much more computing power, you need all these let's call security as not a business value, right? It's not a business value for you. You want your workloads, your applications, the ones that generate revenue, to be using the computing power. Now, security, it doesn't come cheap. Security is compute intensive. You have to scan each of these files, you have to move files around, and there's a lot of signature matching, etc. It doesn't come cheap. Now, traditionally, we had all these on single boxes. So every machine had an antivirus, anti-malware, host intrusion prevention product, etc. Now, that is, if you're going to do all that, what is each of these VMs? You're probably going to have the computing power. So you need to go, you need to think differently. And the thought we have implemented is, a concept of a security appliance. So you create a security appliance, which is a standalone appliance. And what that does is take all the security processing of these guest VMs, guest virtual machines, to this offload scan server. Now, there are two ways of doing it, and I'll go into that. And the one we call multi-platform, because that means it can work on all platforms. We are not tied down to any platform, right? It could be Azure, it could be hypervisor, whatever, Hyper-V, any of these KVMs, anything, right? We can work on any of those. The reason that can happen is we don't care what's here. This box, as long as it can run and we can get all the files, etc., from here to this place, we are good, right? So that is the logic. So as long as we can get it over the network, we can move. We are using the term move, which is called McAfee, optimized for virtual environments. But it also means that we move the files over the network to a security appliance. Now, you may say, that means there's that much more network overload. So for that, we have a variation of that, and that is by implementing cache, local cache and global cache. What that does is, if you have scanned a file once, then it's going to remain in the cache. So next time you don't have to send your file, you just send your signature, you send your thumbprint of the file, right? You send the SHA-1 or MD5 of it. And then over the network, it is compared in a global cache. It says, okay, this file, we have seen it before, it's clean or not clean or whatever, and you just send the result back. So that means that we are not overloading the network anymore. The other advantage is, one of the machines has seen it and has been scanned once. That information is in the global cache. So next time these thousands of VMs come and ask you about a file, you're ready with the answer, right? So you've not done actual scanning. So that's called off-box scanning and reduced scanning. The other advantage we have is McAfee has got a research lab, and what they have done is they have taken their threat intelligence to the cloud. So that is a different way of coming to a solution, right? They have got their research published in the cloud. So now you don't have to rely on the DAT signature every day that you get that says, this is your latest files, we know these are good, these are bad, whatever, right? It is kept real time there. So as soon as any researcher has done any work, it goes there. So which means if we don't know any of these things locally here, then the security appliance can reach out to the cloud and say, look, none of us know about this, do you know about this file? And yes or no, it's an obvious answer. That's the compute power of that is done at the McAfee backend and not here. Right? And once that information is provided here, you can keep it in the global cache, and the rest of it is as always. This is what we call the multi-platform. The next one is specifically for the VMware one, which is primarily VMware also is transitioning to the public cloud using various technologies, etc. But primarily, you can take advantage of VMware tools that gives you information at a hypervisor level. So you don't even need the network anymore. The information is at the VMware level, at the hypervisor level, which means that we don't even need move. We can remove our product from here. And that's called agentless technology, which means we don't have any agents on guest VMs. And we use VMware's tools to let us inspect files on the given hardware. The difference here, though, is that you cannot have a security appliance anywhere. It is on the hypervisor. It is on for every box. You need one secure virtual appliance that McAfee puts. Right. So, but the behavior is the same. It takes away even more. The agent compute also is removed from the guest VM. Any questions so far on what I have talked about? I'm kind of shifting gears a little bit. Go ahead.
You spoke about coexistence so far. You spoke about the coexistence of you discussed.
There are a few things that are there. One is the sandboxing kind of technologies that have come out. The other is we can look at coexisting applications. If a new application comes, whether you allow them to run or not, that kind of technology can be applied. I'll get to that a little bit.
Once you have this security agent hypervisor, you come to know the threats that if you have a private agent, then
so the agent itself does not do any scanning. The agent is only one that is monitoring and is siphoning off files or file signatures to the security appliance. Right? In the security appliance, it says this is the file they're trying to open. Is it a good or bad? So that's only like a more of a handler. It doesn't do any scanning itself.
So where does this actual file reside?
The files reside in the VMs, guest VMs. So this is your workload, right? So you run your workloads on each of them. So this could be web server, this could be application server, it could be tons of those. Right? So files exist on each of these, but the files can be common. It's more, and statistics show that 80% of the files are all the same. So, and especially if you're running similar applications, it's going to be bound to be same. So instead of every machine scanning, we have taken it off. And they've also, so there are two terminologies here. One is offload the scan, which is take away the scan to something else. The other is to prevent DAT storms. DAT are those signatures that you get every morning or nowadays I think we get twice a day. If you get signatures that say the latest threats for handling latest threats. So that storms. So which means that all these machines have to keep getting new updates, which means there's also compute, right? And that has been taken away by a couple of things. One is that you can get real time to the cloud. Whenever you want, you can pick it up. The other is that we can schedule those things. You don't, when the workload is high, when the business is running, why do you want to do a DAT signature update or something else? Do that when the machine is down or on a low compute.
Isn't it one point failure there?
Sorry, there's two questions.
We have time for one last question.
Okay, because I will continue. Okay.
So I would suggest that you continue and then take questions at the end.
Okay, fine. Yes. Other technologies we have got, we can compute if you want to call it a signature or a gold coin, known good as we call it. As a machine boots up, right from the hardware level, we look at registries and other events that happen, and we are keeping a track of what happens, right? And that is kept secure. So which means you do that once, and you keep that as your master. And the next time all these machines, tens of thousands of VMs come up, all we do is just a match. So did this also boot up the same way? Did this also boot up the same way? Did this also boot up the same way? And if not, then I'm not allowing you to get on the network, right? You're out. So that's called the trust attestation or the boot attestation, and JD will cover it.
Historically, most medium to large IT shops have been wary of a public cloud-only model as they wish to maintain control of critical business processes and data. Because of this, cloud adoption was mostly prevalent among startups and mid-sized companies for reasons due to cost, efficiency, and a higher tolerance for risks and compliance. More recently, however, corporations have begun assessing the feasibility of moving more of their computing into cloud environments. The rise of virtualization has been the single biggest catalyst in the growing demand for data centers. Virtualization enables a high level of agility and drives lower costs as proprietary interfaces and solutions are eliminated. Furthermore, virtualization provides quantifiable business savings and organizational flexibility. Now, companies are asking themselves how they can expand virtualization but maintain security. Also, they want to know how they can best avoid operational and risk management challenges.